Hi everyone, my name is Anwar Abdurrahmanov, and today we're going to talk about the assembly logical operations. Our first instruction is and here you can see our source registers R1 and R2 and their binary representation of the values stored in these registers. And the instruction will check in which indexes both R1 and R2 takes the same value 1, not 0 but 1, and mark the same index as 1 in the destination register, which is R3 in our case. Here you can see that 2nd, 6th, 7th, 9th, 11th, and 16th indexes are marked as 1 in R3. Our second instruction is OR. OR will mark the index in the destination register as 1 if at least one of the source registers take the value 1 at the same index. Here you can see that the R4 destination register takes value 1 in the first index from the left-hand side because first index of R2 is 1, even though the first index of R1 is 0. Third instruction is EOR, which is basically an XOR operation. This instruction will mark the index in the destination register as 1 if only one of the source registers take the value 1 at the same index. Here you can see that value of the first index of destination register, which is R5 in this case, is 1 because only R2 takes value 1. But value of second index of R5 is 0 because both of the source register take value 1 at this index. The next instruction is BIC, which stands for bit clear. This instruction will mark the indexes in the destination register as 1, where only the index of the first source register take value 1. Fifth instruction is MVN, which stands for move not. Here we have only one source register, and what will this instruction do is takes the opposite of this source register. Here you can see that the bits that were 1 in R1 are marked as zeros in our destination register R7, and the bits that were 0 in R2 are marked as 1 in R7. The next instruction is LSL, which stands for logical shift left. Here we give one source register and one number, but it can also be the value of another register. LSL instruction will shift the bits in the source register to left by the number of bits provided. In this example, we are given R5 as our source register and number 7 as the number of bits needed to be shifted. As a result, the first bit of R5 from the right-hand side became 8th bit in destination register, and the first 7 bits from right-hand side are fulfilled with zeros. Seventh instruction is LSR, which stands for logical shift right. This instruction will perform almost the same as LSL, except here we are shifting from left to right. Our eighth instruction is ASR, which stands for arithmetic shift right. This instruction will perform almost the same with LSR instruction we talked about before, but the main difference here is that if the leftmost bit of our source register is 1, the shifted bits will take the value 1, and if the leftmost bit is 0, the shifted bits will take value 0. And here you can see that in our source register, the leftmost bit is 1. So in our destination register, the leftmost bits are fulfilled with 1s. The last instruction is ROR, which stands for rotate right. This instruction is similar to LSR, but the difference here is what we do not fulfill the shifted bits by 0, but we are rotating the bits by given number. The rightmost bit will become the 21st bit from the left-hand side, in our case, when we rotate the bits of our source register by 21. That's all from our video. Thank you for your attention.